Welcome to the Chemistry 24-23 video series. In this video I'll be discussing the procedure for taking a melting point. The first thing you'll do when you go into the laboratory is obtain a melting point capillary, which is a thin glass tube. It's about that size, open on one end, and we need to load sample into the capillary tube, the sample of which we'll be taking the melting point, and you'll need a clean flat surface to do that. I like using a watch glass. So here's our watch glass. It takes a very, very small amount of sample. And so it's not a bad idea to have about a BB size piece on the watch glass. If you're not familiar with a BB, a little metal BB is in a BB gun. It's about that size. So we're going to take the sample, the capillary tube now, and ram the end into the sample to force some into the open end of the capillary tube. So we're going to push this down into the sample like so. One of the most common mistakes that I see people make when they're loading sample into the capillary tube is they load too much. It takes a very, very small amount of sample, about that much. And so if you were going to measure that, it would be, I'd say, in the range of about 1 to 1.5, it's 1.5 millimeters of sample. It's a very small amount. So about like that. The next problem you'll be faced with is that the sample is going to be almost always jammed in the very top of the tube, and these are very, very thin capillaries, so you're not going to find too many things that you can force down in there to force the sample down. So there's a couple of easy, common procedures for getting the sample into the bottom of the capillary tube where we need it to take a melting point, and one is to take a long piece of glass tubing, like so, and you're going to put that flush with the bench. And you're going to place the capillary inside that and just drop it. So there's the capillary, and we're going to drop it in the tube so it bounces on the top of the bench. It'll bounce up and down a few times. And if the glass tube is long enough, that will knock the sample into the base of the capillary where we need it right there. So that's the procedure for preparing the capillary tube, the capillary tube containing the sample. So now we're ready to place the capillary tube into the melting point apparatus. And you'll be using a digital melting point apparatus that looks something like this. It's got a cylindrical sample holder. At the base of that cylinder, there is a lens that magnifies the base of the sample. That's that very small amount of sample, so that's magnified so it's easier to see. And this is digital, so there'll be a digital display that shows you the temperature. And so the capillary, there's actually 3 small sample holders inside this cylinder, so you can have more than one capillary tube at any given time inside the melting point apparatus. And again, your sample is magnified through the lens there. So there are 3 things that you're going to have to program into the melting point apparatus to take the melting point. The first one is the start temperature. Okay, that's acceptable. So the first thing you're going to program is the start temperature. And the start temperature should be about 15 degrees below the expected melting point. Say below the melting point. So this is assuming you know the melting point. We'll talk about what to do if you don't know the melting point in a moment. So that's the first thing to program. The second thing to program is the ramp rate. That's the rate at which the temperature will be rising in the range of your melting point. The faster the ramp rate, unfortunately, the less accurate your melting point and melting range is going to be. So as kind of a trade-off between speed and accuracy, we typically do that set this to about 1 degree Celsius per minute. So it's rising at a temperature of 1 degree Celsius per minute as we get in the range of the melting point. The third and final thing to program is the stop temperature. And just to be on the safe side, we set that a healthy 15 degrees above the expected melting point. Above the melting point. You don't have to wait that long. If the sample was melted before this, you can stop it, of course. So that's just to give you a range so that the ramp rate doesn't stop before the sample is completely melted. So once you've done that, you start it off. What's going to happen? You press start. The temperature will rise very rapidly to the start temperature, and then it slows down to the ramp rate. And at that point, you need to be watching this very carefully. So your eye's going to be kind of moving back and forth between the temperature and the sample. And at some point, what you often see is the sample will kind of slump a little bit. It doesn't always do that, but it tends to do that. It kind of compacts as it gets hotter. And eventually, you're going to see a little tiny bit of liquid, and that is the beginning of what's known as the melting range. So the melting range is defined as that temperature where you first notice liquid. That's the beginning of the melting range. So that first little drop of melting is the beginning of the melting range. The end of the melting range is when the last bit of sample is melted. That's known as the clear point. So it ends at the clear point. It's that temperature where the very last bit of sample melts. And so you always record melting ranges. Typically, pure compounds have very sharp melting ranges. Now, we often report what are known as melting points. So what's the difference between a melting point and a melting range? The melting point that we'll be using, the definition for melting point we'll be using, is going to be the midpoint of the melting range. So halfway between, it's right in between, halfway in between where the sample first begins melting, where you first notice liquid, and the clear point where the last bit of sample is melted. So this is the midpoint of the melting range. And so that's the procedure for taking a melting point. One more thing that I should mention here is what to do in the case of an unknown sample. That is a sample where you don't know where the expected melting point is going to be. Where do you set your start temperature? The best thing to do in those situations is to go through a broad range, and that is from about room temperature up to about 260 degrees, so for unknowns. Set a ramp rate, a very high ramp rate. You don't want to spend a lot of time on this, of about 20 degrees Celsius per minute. That's really fast. Up to approximately 260 degrees, where, most organic compounds are going to melt below 260 degrees. Either that or they'll decompose, they'll burn. So you keep an eye on it, and you're going to find out the approximate melting point in that range. And so say that you see it melting at 150, then you're going to go back and redo the melting point using the procedure we did up here. So you'll set the start temperature at 15 degrees below the approximate melting point you saw when you did this really rapidly. So this just gives you an idea of where it melts. So then you go back and redo it following the procedure above. And you again set the ramp rate at 1 degree Celsius per minute, 15 degrees either side of the melting point you observed when you did this very rapidly. So hopefully that makes sense. So that's it. Make sure you put this procedure in your lab notebook. There will be another part to this melting point video discussing some of the theory and background of melting points, how pure compounds differ from mixtures and so forth. So please watch that as well. And I will see you in the laboratory. One more thing, just to make certain that I know that you've seen the lab video, I'd like you to just mention in your procedure the color that I used to illustrate the melting point apparatus in this video. So good luck, and I'll see you in lab.